Alright, this is 7.3, finding n for a proportion. We're going to be using the calculator. This is practical. We could do it by hand, but this is easier. Alright, quality control expert wants to estimate the proportion of defective components that are being manufactured by his company. A sample of 300 components showed that 20 were defective. How large a sample is needed to estimate the true proportion of defective components within 2.5 percentage points with 99% confidence? Alright, so we need to identify p hat, q hat, z alpha over 2, our error, and just plug it into this formula, just like we did when we were finding the sample size needed back in 7.1. So, p hat is just going to be 20, which is the number of successes, divided by 300, the number of samples we took. So, open parentheses, 20 divided by 300, close parentheses, open parentheses. Q hat is going to be the complement of that, so it's 280 out of the 300, close parentheses. Now, in order to get the z alpha over 2, we're just going to grab the inverse norm of alpha divided by 2, with 0 and 1 being mu and standard deviation. So, open parentheses, inverse norm of 0.01 divided by 2, comma 0, comma 1. Now, on the newer calculators, and you'll see it in a second, it gives you a drop-down menu, and you enter in the values. 0 is mu, 1 is your sigma, and then your area is going to be 0.01 divided by 2. Your area is the alpha. Kind of nice, that area in alpha A, right? All divided by our error, which is 2.5%. So 0.025, close parentheses, squared. I'm literally just plugging it into the calculator, but let's see how it's plugged into the calculator, because that can get tricky. There's a lot of division and a lot of parentheses. Alright, so, open parentheses, 20 divided by 300, close parentheses, open parentheses, 280 divided by 300, close parentheses, open parentheses, second distribution, inverse norm of our alpha, which is 0.01 divided by 2 because it's half of the area, comma 0, comma 1 because we're doing a z value. Alright, this is what we need to do because we're getting the idealized value. Close parentheses, and that ends the inverse norm, so now we can divide by our error, so 0.025. Close parentheses for this whole portion, raise it to the second, hit enter, and we got our answer of n is approximately 660.54. Remember, we always have to round it up to the nearest whole, no matter how low it is. Even if that was 660.3, I would still round up the final answer to 6601. So n is equal to 66.1 because we have to overestimate it.